Power grinders come in different sizes and speed ranges. The size of a power grinder is the diameter of the largest wheel or disc it takes. Wheels and discs have a maximum safe speed printed on them. This maximum must never be exceeded, or the wheel or disc could disintegrate. Every well-equipped workshop has a solidly mounted grinder, either on a pedestal bolted to the workshop floor or securely attached to the workbench. Eye protection must be worn when grinders are being used, and the wheel guards must be firmly in place. A bench grinder or pedestal grinder has a rating with the size of the grinding wheel it can take. Mounted grinders take grinding wheels in grades from coarse to very fine, depending on the size of the abrasive grains that are bonded together to make the wheel. They range in hardness too, depending on the abrasive used and the material that bonds the particles together. If a particular grinding application is required, a check should be done to find out the most suitable grinding wheel for it. A straight grinder, or more commonly an angle grinder, is needed when the bench grinder is not appropriate. The straight grinder takes conventional grinding wheels, just like the stationary grinders, although they're limited to a grinding wheel diameter of about 125 millimeters. The angle grinder uses discs rather than wheels. During grinding, the face of the disc is used instead of the edge. There are special discs that can be used for cutting. They use the edge of the wheel and are useful for jobs that can't be reached with a hacksaw. The most common pullers have 2 or 3 legs which grip the part to be removed. A center bolt is then screwed in, producing a jacking or pulling action which extracts the part. A punch transmits the hammer's striking power from the soft end down to the tip that is hardened high-carbon steel. A punch makes an accurate blow at exactly one point, something that can't be guaranteed with a hammer. There are some points drawn on this plate to help locate a hole to be drilled in it. A prick punch is used to mark the points so they won't rub off, and scribe some intersecting lines between them. Its point is very sharp, so a gentle tap leaves a clear indentation. It's easier now to draw the lines based on permanent marks. This center punch isn't as sharp as a prick punch, and it's usually bigger. It makes a bigger indentation, called a center, that'll center the drill at the point where the hole must go. That's where the name center punch comes from. The pin punch is available in various diameters. It's used to drive out rivets or pins. A lot of components are either held together or accurately located by pins. Pins can be pretty tight, and a group of punches is specially designed to deal with them. This is a starter drift punch. Starter, because you should always use it first to get a pin moving. It has a tapered shank, and the tip is slightly hollow so it doesn't spread the end of a pin and make it an even tighter fit. Once the starter drift has got the pin moving, a suitable pin punch will drive the pin right out or in. Special punches with hollow ends are called wad punches or hollow punches. They're the neatest tool to make a hole in soft sheet material like shim steel, plastic, leather, or most commonly in a gasket. There should always be a soft surface under the work, ideally the end grain of a wooden block. If a hollow punch loses its sharpness or has nicks around its edge, it'll make a mess, not a hole. Numbers and letters, like engine numbers on a cylinder block, are usually made with number and letter punches that come in boxed sets. The rules for using them are true for all punches. The punch must be square with the surface being worked on, not on an angle. And the hammer must hit the top squarely. There are so many applications for rivets that there is a variety of types and tools for doing the riveting. The concertina rivet gun, sometimes called lazy tongs, puts larger rivets in heavy materials. Riveting pliers are convenient for occasional riveting of light materials. The rivet goes into this riveting tool, which will pull this end of the mandrel back through the body of the rivet. Because the head is bigger than the hole through the body, it'll swell out as it comes through. Finally, the mandrel will snap under the pressure and fall out, leaving the rivet body gripping the two sheets of aluminium together. This is a typical pop or blind rivet. It has a body which will form the finished rivet, and this mandrel which will be discarded when the riveting's done. It's called blind because there's no need to see or reach the other side of the hole in which the rivet goes to do the work. In some, the rivet is plugged shut, so it's waterproof or pressure-proof. For just one hacksaw frame, there's a range of hacksaw blades to cope with different materials and situations. The hacksaw frame can be adjusted to take different blade lengths. The blade is placed in the frame and tightened to the correct tension with this wing nut. The blade must be of the right pitch. That's the number of teeth in an inch of blade. A blade with many teeth per inch has a fine pitch. One with few teeth per inch has a coarse pitch. The saw blade cuts on the forward stroke only. The teeth gather the metal being removed. They can only get rid of it when they come clear of the cut. If a blade cutting through a thick section of metal has too many teeth, in other words, the pitch is too fine, they'll clog up and stop cutting. On the other hand, when cutting a piece of sheet metal, the blade shouldn't be too coarse or the saw teeth will be stripped. With the saw flat across the section being cut, at least 3 teeth should touch the metal at that point. After the job is done, the tension on the blade should be loosened to prevent the frame from distorting over time. Cutting large holes in panel steel or thin sheet metal is done by a hole saw. The drill in the center locates the saw accurately and leads it into the surface. Repetitive cutting through thick sections of material can be hard work unless you have an abrasive cutoff saw. These are rated in different sizes, usually from about 250 millimeters to 500 millimeters. That refers to the largest diameter cutting wheel that should be fitted to them. This is a powerful tool and it demands every precaution. Wear protective clothing with nothing hanging out or loose, especially long hair. Cover long hair with a snood cap. And of course, wear safety glasses or a full face shield. The guard on the saw should be properly in place and the power cord well away from the cutting wheel. There are enough sparks flying when the saw is working without cutting through the power cord as well. The range of those sparks should be limited by a safety screen around the job. The correct screwdriver to use depends on the type of slot or recess in the head of the screw or bolt and how accessible it is. Most screwdrivers can't grip as securely as spanners, so it's very important to match the tip of the screwdriver exactly with the slot or recess in the head of a fastener. Otherwise, the tool might slip, damaging the fastener and, worse still, you. When using a screwdriver, always check where the screwdriver blade can end up if it slips off the head of the screw. A screwdriver can't tell the difference between a piece of steel and a piece of yew. The most common screwdriver has a flat tip or blade, which gives it the name blade screwdriver. It's easy to see the blade should be almost as wide as the slot in the fastener, so that twisting force applied to the screwdriver is transferred right out to the edges of the head where it has the most effect. Not so easy to see is that the blade should be a snug fit. Then the twisting force is applied evenly along the sides of the slot. This guards against the screwdriver suddenly chewing a piece out of the slot and slipping just when most force is being exerted. Side on, the blade tapers until the very end where the tip fits in the slot. If the tip of the blade isn't clean and square, it has to be reshaped. When you use a blade screwdriver, support the shaft with your free hand as you turn it. This helps keep the blade square onto the slot and centered. Slipping screwdrivers are a common source of damage and injury in workshops. A screw or bolt with a star-shaped recess needs a Phillips or a posi-drive screwdriver. The star-shaped slot holds the tip of the screwdriver securely on the head. The Phillips tip fits a tapered recess while the posi-drive fits into slots with parallel sides in the head of the screw. A Phillips or posi-drive head can be pushed and twisted with more confidence. But again, the screwdriver must be the right size. This is simplified with these two types because 4 sizes are enough to fit almost all fasteners with this sort of head. The Allen key is designed to be a snug fit in screws with a socket head. The socket and the key are hexagonal in shape, and there's a correct size key for every socket. So Allen keys come in sets. They can be in either the metric or imperial system, and are categorized in millimeters or fractions of an inch, according to the distance across opposite flats of the hexagon. They give the best grip on a screw or bolt of all the drivers, and their shape makes them good at getting into tight spots. The offset screwdriver fits into spaces where nothing else will, and where there's not much room to turn it. The two tips look identical, but one's at 90 degrees to the other. This is because sometimes there's only room to make a quarter turn, which is exactly what happens by using the ends of an offset screwdriver alternately. The ratchet is a popular screwdriver handle that usually comes with a selection of flat and Phillips tips. It has a ratchet inside that turns the blade in only one direction, depending on how the slider is set. If it's set there, a screw can be undone without removing the tip of the blade from the head of the screw. Slide it back, and the screw runs in just as easily. This is an impact driver. A screw or a bolt that's rusty or over-tightened needs a tool that can apply more force than the other members of this family. The impact driver takes a variety of tips. Choose the right one for the screw head, fit the tip in place, and then tension it in the direction it has to turn. A sharp blow with the hammer breaks the screw free, and it can be unscrewed. Socket spanners are a good choice where the top of the fastener is reasonably accessible. The socket fits onto it snugly and grips it on all 6 corners. That's the grip needed on any nut or bolt that's extremely tight. Sockets also come in deep wall sizes. These are ideal for removing or tightening spark plugs or nuts screwed onto long protruding threads. This socket has 6 flats instead of the common 12-point design. It's specially made for impact wrenches that exert a lot more pressure than turning sockets by hand. Socket spanners always need an attachment to turn them. This is done by a range of accessories, many of which are included in socket tool sets. The connection between the socket and accessory is made by a square drive. The larger the drive, the heavier and bulkier the socket. The 1/4 inch drive is for small work in difficult areas. The 3/8 drive handles a lot of general work where torque requirements are not too high. The 1/2 inch drive is for all-round service. The 3/4 inch drive is for large work with high torque settings. These are extensions. Many fasteners are located in positions where access can be difficult. Many lengths of extensions are available to bring the drive point out to where a handle can be attached. A universal joint can be used with an extension and takes the turning force that's to be applied through an angle. A speed brace is the fastest way to spin a nut on or off a thread by hand, but it can't apply much torque to the nut, so it's mainly used to remove a nut that's already been loosened, or to run the nut onto the thread until it begins to tighten. The most common socket handle, the ratchet, makes easy work of tightening or loosening a nut where not a lot of pressure is involved. It can be set to turn in either direction, and it doesn't need much room to swing it. It's built to be convenient, not super strong, so too much pressure could damage it. For heavier tightening or loosening, an adjustable offset handle or breaker bar gives the most leverage. It does need plenty of room, however. When that's not available, a sliding T-handle may be more useful. Both hands can be used, and the position of the T-piece is adjustable to clear any obstructions to turning it. There are many types of spanners. Choosing the one to use usually depends on just two things. How tight is the fastener? In other words, how much force is going to be applied to it? And how accessible is it? How much room is there to get the spanner onto the fastener and then turn it? It's always possible a spanner will slip. Anticipate what will happen if it does before putting a lot of tension onto the spanner, and pull a spanner towards you rather than pushing it away. Ring spanners grip a fastener at the corners just like a socket spanner, the sort of grip needed if a nut or bolt is very tight. Ring spanners have different sized heads at each end. It isn't as convenient as a socket, but it'll go places a socket can't, and still let plenty of force be applied. One disadvantage of the ring spanner is that it can be slow and awkward to use once the nut or bolt's been loosened. Open-end spanners slip easily and quickly onto fasteners, and that's particularly important for nuts and bolts in awkward places. The angle on the head allows it to be used in two different positions. While an open-end spanner often gives the best access to a fastener, if it's extremely tight, the open end shouldn't be used. This spanner only grips across two flats. If the jaws flex slightly or the flats don't fit tightly between them, the spanner can suddenly slip when force is applied. Use a ring spanner to break such a bolt or nut free, then the open end. The open end spanner should only be used on fasteners that are no more than firmly tightened. The combination spanner is a good tool in a tight spot. It has a ring on one end for gripping and breaking the fastener's hold, and an open-ended spanner of the same size on the other end. This is a more convenient way of turning a loosened fastener in a confined space. A variation on the open-end head is the flare nut spanner. It gives a better grip because the flats meet on 5 sides, not 2. The open 6th side lets the spanner be used on nuts and fittings associated with pipes and tubing. But again, don't use the flare nut spanner on extremely tight fasteners. The jaws may spread, damaging the nut. A spanner will only do a job properly if it's the right size for the nut or the bolt to be turned. The size used to describe a spanner is the distance across the flats of the nut or bolt to be turned. It can be metric in millimeters or imperial in inches. 2 systems with a range of spanners especially made for each one. The systems can be identified on the spanner by either a number for metric spanners or a fraction followed by AF. Another system once widely used in the United Kingdom was the Whitworth system. It used fractions, but they did not refer to the distance across the flats of the fastener. Some older British and Australian machines use Whitworth size fasteners. Some Whitworth sizes are not interchangeable with metric or imperial systems. There are a few spanners from one system that are the same size as those in another. But as a general rule, spanners from one system should not be used to work on nuts and bolts from the other. These are adjustable open-end spanners, usually referred to as shifting spanners or simply shifters. The lower jaw can be moved to fit any fastener size within the spanner range. Shifting spanners should only be used if the correct sized spanner is not available. Both the fastener and spanner could be damaged if they are used on really tight bolts or nuts. Threads are cut on screws, bolts, nuts, studs, and inside holes to allow components to be attached and assembled. There was a time when there were many different thread designs used throughout the world. Modern vehicles still use a range of thread patterns, but due to standardization, it's getting simpler. Nearly all the nuts, bolts, screws and studs on a vehicle have a V-thread cut into them. For something that isn't a V-thread, look at a screw jack or a clamp. They have a square thread. The pitch of a thread is the distance between these crests. It's measured by a thread pitch gauge which comes in sets. By laying these blades along the bolt, it's easy to find one with teeth that fit neatly into the thread. This pitch is 12 teeth per inch. Thread tables show what size hole has to be drilled and what size tool is needed to cut the right thread for any given size bolt. It shows that a 3/8 inch bolt can have a coarse thread or a fine thread. This is because some threads grip metals that are brittle or soft and require more metal in the thread. They need coarse threads. A thread in a steel nut can be much finer. The thread on this engine stud is coarse on the end that screws into the cylinder head, and fine for the steel nut that tightens the exhaust manifold to the cylinder head. Fine threads give more grip for a given torque than coarse threads. Taps cut threads inside holes or nuts. This is a taper tap. It narrows at the tip to give it a good start in the hole where the thread is to be cut. This piece of steel is being tapped with a metric thread to take a 10mm bolt. Tapping size tables then give the right drill size for the hole. The taper tap can tap a thread right through this piece of steel. This is an intermediate tap and a bottoming tap. To tap a thread into a hole which doesn't come out the other side, called a blind hole, an intermediate tap is used, then a bottoming tap to take the thread right to the bottom of the blind hole. This tap wrench comes with a set. It has a right-angle jaw that matches the squared end which all taps have. To cut a thread in an awkward space, this T-shaped tap wrench is very convenient, but harder to turn and to guide accurately. Screw extractors are used if a screw, stud or bolt snaps off in the threaded hole. A common type of extractor uses a coarse left-hand thread formed on its hardened body. After a hole is drilled in the center of the broken screw, the extractor is screwed in. The left-hand thread grips the broken part and unscrews it. This extractor is marked with the sizes of the screw it's designed to remove and the hole which needs to be drilled. To cut a brand new thread on a blank rod or shaft, a button die held in a die stock is used. The button die is split so that it can be adjusted more tightly onto the work with each pass of the die, as the thread is cut deeper and deeper until the nut fits snugly. The die nut is more common in the workshop. It's hexagonal to fit a spanner, and it's mostly used to clean up threads that have been damaged. The bench vise is a plain vise that'll hold anything that needs sawing, filing or chiseling. The jaws are serrated to give extra grip, and they're also very hard, which means that when the vise is done up tightly, the jaws can mark whatever they're gripping. To prevent this, a pair of soft jaws can be fitted whenever the danger of damage arises. They're usually made of aluminium or some other soft metal. Some things can be awkward to grip vertically in a plain vise, so there's another style called an offset vise. These slots in the work table of this drill are designed for a drill vise. To hold something firmly and drill it accurately, it has to be secured in the jaws of the vise. Move the vise until the precise drilling point is located. Then tighten these bolts to fix the drill vise in place during drilling. A G-clamp's name comes from its shape. It can hold parts together while they're being assembled, or maybe drilled or welded. It can reach around awkwardly shaped pieces that won't fit in a vise. And it's portable, so it can be taken to the work. This is a torque wrench, also called a tension wrench. It tightens bolts and nuts using the drive on the end which takes any sockets and accessories found in an ordinary socket set. What makes this a special way to tighten fasteners is a scale that allows how tightly the nut or bolt is being done up. This head bolt is being tightened to a specific torque recommended by the manufacturer as being tight enough to ensure that the nut won't come loose, and the parts are held together firmly, but not so tight as to risk breaking the bolt or stripping its threads. Manufacturers don't specify torque settings for every nut and bolt, but when they do, it's important, and that's why the torque wrench is such an important tool. The pipe wrench grips pipes and tubes, and it can exert a lot of force to turn them. Putting more pressure on this wrench tightens its grip more and more. The jaws are hardened and serrated, and increasing the pressure also increases the risk of marking or even gouging metal from the pipe. A wheel brace is a specialized wrench. This model has 4 different sockets, one on each arm. Never hit or jump on a wheel brace when loosening wheel nuts. If the brace won't remove them, use an impact tool. When using the wheel brace, the force provided with your hands is adequate to secure the nuts properly. This specialized wrench is an oil filter removing tool, which gives that extra leverage when oil filters are tight.